Use the summation properties and formulas to compute each sum. Notice these sums are expressed using sigma notation or summation notation. First, we have the sum from m equals 1 to 9 of m cubed. If we were to expand, m first takes on the value of 1, and we plug 1 in for m into the formula m cubed, which gives us 1 cubed, plus now m takes on the value of 2, which gives us 2 cubed, plus m takes on the value of 3, giving us 3 cubed, plus m takes on the value of 4, 5, 6, 7, 8, and then 9, and then stops. Notice 9 is the upper limit of the index, so we have plus dot 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 plus 9 cubed. But we want to use a formula to determine the sum, so analyzing the notes below, we use this third row where we have the sum from I equals 1 to n of I cubed. Notice we're using this formula because here we have I cubed, and our formula is m cubed. Notice the variable of the index matches the variable of the formula. And the sum from I equals 1 to n of I cubed equals n squared times the square of n plus 1, all divided by 4. In our case, notice n is equal to 9, which indicates our sum is equal to 9 squared times the square of n plus 1 is going to be the square of 9 plus 1, or the square of 10, all divided by 4, which is equal to 81 times 100 divided by 4. 100 divided by 4 simplifies to 25. The sum is equal to 81 times 25, which equals 2025. For the second example, we have the sum from q equals 1 to 15 of 5q cubed. Before we can apply one of the formulas below, though, we do have to factor out the 5 using our summation properties. The given sum is equal to 5 times the sum from q equals 1 to 15 of q cubed. This indicates the sum is equal to 5 times the sum from q equals 1 to 15 of q cubed is equal to, again, when n is 15, we have the square of 15 times the square of 15 plus 1, or the square of 16, all divided by 4, which gives us 5 times 15 squared is 225, times 16 squared, which equals 256, all divided by 4. And 256 divided by 4 is equal to 64. The sum from q equals 1 to 15 of 5q cubed equals 5 times 225 times 64, which equals 72,000. For the third example, we have the sum from r equals 6 to 18 of r cubed. We need to be careful here. Notice the lower limit is r equals 6, not r equals 1, and therefore we cannot apply the summation formulas with the sum in this form, but the sum from r equals 6 to 18 of r cubed can be expressed as a difference of two sums, as the sum from r equals 1 to 18 of r cubed. Notice the original sum has 5 less terms, or the sum from r equals 1 to 5 of r cubed. So we subtract the sum from r equals 1 to 5 of r cubed. Notice the difference of these two sums will give us the original sum. And now we can use the summation formula for the sum of I cubed to determine the difference of these two sums. For the first sum, we have n equals 18, and therefore the sum is equal to 18 squared times 19 squared divided by 4. And then we have minus the sum from r equals 1 to 5 of r cubed is equal to 5 squared times 6 squared divided by 4. 18 squared equals 324. 19 squared equals 361 divided by 4, and then minus 5 squared is 25 times 6 squared is 36 divided by 4. Simplifying, 324 divided by 4 simplifies to 81, and 36 divided by 4 equals 9. The original sum equals 81 times 361 minus 25 times 9, which equals 29,016. I hope you found this helpful.